We define pollution as anything that reduces ecosystem services, carrying capacities, and biodiversity in a habitat. We've defined 5 categories of pollution: noise, light, air, water, and land pollution. In addition to these 5 categories of pollution, we can also categorize pollutants as either being point or non-point. Point sources of pollution come from a single source. We can point to the single source of that pollutant, whereas non-point pollution comes from a variety of sources and is harder to pinpoint. Whether a physical substance becomes a pollutant depends on its molecular qualities as well as the concentration in which it's found in the environment. Some substances are considered pollutants at any concentration because they are that dangerous and disruptive to a habitat. Most substances, however, have a certain threshold above which they're a pollutant and below which they are not. For example, in order for mercury to start to cause habitat disturbances, it has to be above a concentration of 0.01 parts per million. In order for a pesticide called DDT to disrupt ecosystems, it has to be found in concentrations above 5 parts per million. The concentration necessary for something to disrupt an ecosystem also depends on whether or not that substance can biomagnify. Biomagnification is the process in which the substance becomes increasingly concentrated as it moves up the food chain. For example, consider DDT, the pesticide we mentioned earlier. If DDT is found in the environment, it will be consumed along with other substances by plankton at the base of the food chain. Those DDT molecules will accumulate in the tissue of that plankton as they go about their lives and continue to feed. Plankton is continuously fed on by small fish. As a fish eats each plankton organism, it accumulates more and more DDT within its own tissue. Eventually, the fish will have tissue concentrations as high as 100,000 times what was originally found in the environment. This process will continue as those small fish are consumed by large fish. So for example, if a bass eats those small fish, every time it eats a fish, its concentration of DDT will increase more and more, eventually reaching levels that are 1,000,000 times higher than what's found in the environment. If an eagle or other large bird of prey eats that fish, it will accumulate that much DDT every time it eats one of those fish. And so eventually an eagle's concentration of DDT may be 10,000,000 times greater than what's found in the environment. Not all pollutants are biomagnifiable, but those that do biomagnify pose an extra risk to the environment. This week we are focusing on land and water pollution. Land and water pollution are often interconnected, as what begins as soil pollution often makes its way into bodies of water. One of the leading causes of land and water pollution in the United States is agriculture. In particular, agriculture is a leading cause of eutrophication. Eutrophication is the process in which dissolved oxygen in aquatic ecosystems is reduced due to excessively high nutrient levels such as nitrogen or phosphorus. Nutrients like nitrogen and phosphorus make their way into aquatic ecosystems from nearby fields. This causes the growth of thick algae mats which block out sunlight to aquatic ecosystems. This reduces photosynthesis from aquatic plants, reducing both the production of oxygen and food for the rest of the food chain in that aquatic ecosystem. As oxygen levels are reduced and species begin to die, oxygen levels are reduced even further as they decompose. Eventually, this reduction in oxygen can create what are called dead zones in bodies of water, where no species can survive or exist due to low oxygen levels. One way that farmers can reduce the risk of eutrophication in aquatic bodies of water is by adopting what are known as best management practices. These are practices that reduce nutrient runoff into bodies of water, reducing the risk of eutrophication while still working in conventional agricultural systems. This week we will also talk about thermal pollution and plastic pollution. Thermal pollution occurs when temperatures increase in an ecosystem to an extent that it disrupts ecosystem function. This is especially at risk for aquatic ecosystems because the amount of dissolved oxygen in water depends in part on the temperature of that water. The warmer the water, the less oxygen. Lastly, we will also talk about the global ramifications of our widespread use of plastics. Plastics don't actually break down or decompose in the environment. They just become smaller and smaller and smaller until they're the size of tiny particles that we call microplastics, which can be toxic to living organisms.